Hello there, my name is Michael Maynard and welcome back to Gorilla Picking. Now, you are watching part 2 of the Group 2 Safe Lock series. What we are going to discuss today is the definitions of a Group 2 Safe Lock. So why is it called that and what does it mean? And secondly, we are going to talk about the user interface. We're going to talk about this bit here, which is on the front of the safe itself. It's the only bit of the lock that you can see. Alright, so let's have a think about the definitions first. The definitions were put together by a firm called Underwriters Laboratories, that's what that UL stands for, and those definitions are about 100 odd years old. So these are very, very old standards. Underwriters Laboratory is an industry group set up by the insurance industry that certify a whole lot of things, not just locks, as being able to do whatever it is that they are supposed to do. So there are certain standards, and what are those standards? Well, first thing is a Group 2 lock should be able to withstand 2 hours of semi-skilled, if you can read my scrawl, manipulation. Now, if you are skilled at manipulating one of these things, let's say you are a safe engineer and you do this all day, every day, an average time for getting into one of these, unless you happen to get a lucky lock, is about 20 minutes. Now, the average burglar on the street, on the other hand, is not semi-skilled. He isn't skilled. He is basically a goon who's trying to get some cash, okay? So semi-skilled means a bit better than the average dumb burglar. All right, second thing. It has to have a thing called a relocker. Now, we are going to talk about relockers in great detail in another video, guys. But in essence, what the relocker is this little sprung-loaded piece of metal here. And for now, what I want you guys to think of this as a fail-safe device. So you imagine you are in a train or a trolley bus, something like that. The driver dies at the wheel and there's a dead man switch that will stop the trolley bus or the train. Right, this is kind of the equivalent of that. That's what a relocker does, and again we're going to talk about that in much more detail and why it's there in another vid. Alright, next thing we got is a million differs, a million different combinations. Now that is just a very simple way of saying that the user interface has to have a total of 100 possible numbers, and you need to dial 3 different numbers to the combination. So 100 times 100 times 100 equals 1 million. But then you come to an absolutely fascinating thing, which is the tolerances of the lock. Now, in 2 seconds' time, you guys are going to be scratching your heads and laughing, because Underwriters Laboratories, want the tolerances for this lock to be not worse than plus or minus 125 numbers. Now, about 2 seconds thought will tell you that those two things are actually mutually exclusive, all right? So if you have got, let's say one of the numbers on your combination is 0, right? Now those dial tolerances say that if you dial 1 1/4, that lock should still open, and if you dial 98 3/4, that lock should still open on that number. So immediately you can see that we have got many fewer than a million different combinations we can possibly use. The number is more like about 400,000 in fact, and in actual fact it's even lower than that, because there's a thing called the forbidden zone for the third number, which we'll discuss later on as well. So what I'd like you guys to realise at the moment is that even though there are in theory a million different possible combinations, the fact that we need to make this lock usable by the average Joe in the street means that we've got many fewer numbers to work with. Now, we could make this lock as difficult as we like, all right? So let's say we decided that the dialing tolerances were plus or minus half a number. So it'll open on 0, but it won't open on 3/4 and it won't open on 99 1/4, let's say. That would make a far more complicated lock and a far more secure lock, but the average Joe in the street wants to be able to just spin this to the number reasonably accurately. He's not concerned about going to a quarter of a number, and so it would make the lock so difficult to use that a lot of folks just couldn't use it. So that's why those two numbers look as mutually exclusive as they do. They are there to do two slightly different things. All right, now that brings me on to the user interface, and the user interface is tightly wrapped up with these definitions. As you can see, you kind of can't have the one without the restraints of the other. When you look at a lock from the front, what you will see for a start is that it is a circular dial. That's pretty self-evident, with 100 different numbers on it from 0 to 99. Okay, so far so good. Now there are some other weird things going on there as well. What is this little mark here? Well, this is called the dialing index. Now, with safe locks, there is a whole vocabulary that you've got to learn, guys, and I will be introducing you to these concepts step by step. What you need to know is, when you are dialing the combination, you need to dial the numbers fairly accurately to this index here. This is the dialing index. Now, what the hell is this one round here? Well, that is a thing called the change index. And again, we're going to come to this later, but it is part of the user interface, so you've got to know about it. That is so that if we dial the combination to this index here, on this particular type of lock, we can then insert a key into the back of the lock and change the combination. It's a thing called a key change lock. Now, very often, the average Joe in the street gets these two things muddled up, and you can see how if you were under a bit of stress, let's say you had to dial this thing quickly, okay, you could very easily get this index and that index mixed up. And if you talk to any safe engineer, you will discover that a very common cause for lockouts is that the poor old user has thought he got the combination right, and in fact he's got the numbers right, okay, but he didn't actually manage to get them in the right place here. You know, he dialed the first one to line up with this one, and then he made a mistake and the second one lined up with that one or something. So folks will very often lock themselves out just because they've got the dial indexes muddled up. Now, the other thing that you'll see on this one here, you will see a nasty, scummy little wafer lock there. That really doesn't provide a whole lot of security at all, but it does have a couple of jobs. First of all, it makes the guy who owns the safe feel a little bit better. If the guy who owns the safe can lock the dial in position, he just feels a little bit safer about his lock. People like to have a key. They like to have something they can hold and take home. And so having that little key to lock the dial in position so it can't be turned gives the owner that extra little bit of security. The other thing that it can do, on some locks, you can actually use this to lock the safe open. So let's say you've spun your combination, you've dialed the thing open, the lock is now open. What you can then do is lock this dial in position so that the lock cannot be bumped, and so that this thing stays open and unlocked until further notice. As I'm sure you know, not all safe locks have this. It isn't a specific feature of a Group 2 lock. Some Vault locks have it, some Group 1 locks have it, some locks don't have it at all. So it is just an extra little thing. But if you were looking for good features to put on your dial to sell it, then that would actually be a very good thing. Now, next thing we need to talk about is the way that we actually dial the combination. So we are still talking here about user interfaces and how the lock works. Now, the vast majority of Group 2 locks open in one major way, and listen, gentlemen, this is one of the fundamentals. You got to get this right, okay? what you need to do is dial the lock round 4 times anti-clockwise, so to the left, to the first number, whatever it is. You then dial it 3 times to the right, to the second number. You then dial it twice round to the left again to your third number, and then you turn it right once until it stops. And what happens when it stops? It's the lock. Let's not get too complicated. At that point, when it stops, the lock opens. Now, the thing that I really want you guys to remember here is that dialing sequence is crucial. That's part of the user interface that punters will get wrong very often. That 4 times to the left, 3 times to the right, twice to the left, and right to the drop is complex for people to remember under stress or under pressure. And again, it's something that often gets wrong. And that brings me to my last and final thing that I'm going to talk about on this video. We've already had 11 minutes, unbelievably. What I want to talk to you about just very briefly is the philosophy, the science, and the real complex things behind this lock. What a lock with a key does, it looks for a shape, okay? A lock, let's say an ordinary pin tumbler lock, is a shape checker. It wants to know, does the user have the thing with the shape? So that's the bitting of the key to get the lock open. Now, these locks are more complex than that. A safe lock wants to know if the user has information in time and space. Now again, we're getting very deeply philosophical here, guys. This is complex, high order stuff that we're discussing, okay? But you as the user need to be able to input data into this user interface and get it accurate in both time and space. Time is the order in which you dial these numbers. Did you get the order right? Did you dial the number 10, 20, 30, not 10, 30, 20, let's say, all right? What you did there was you had the numbers right, but you had the order wrong. That's an issue with time. And then obviously the order with spaces, do you have these numbers in the dial in the right position? So first of all, did you get the right combination? Did you get 10, 20, 30? If that happens to be the number that opens the lock. Secondly, did you manage to get them in the right position with respect to these index marks? So a safe lock is far more complex and is doing much more philosophically complex things than a lock with a key to it. A key wants to know about a shape. A safe lock, I tell people it's like a TARDIS. It wants to know, does the user know about stuff in time and space? And there we're going to leave it, gentlemen. 13 minutes of definitions of Group 2 safe lock and considerations on the user interface. My name's Michael Maynard. This is Gorilla Picking, and the next one we do of these, I don't know what it's going to be on actually, but we'll find out shortly.